Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for special probability distribution for the case normal distribution. Kindly refers to the questions. If X is normally distributed with the mean 2 and the variance 9, find the following probability by using the standard normal distribution table. So before we further our discussion, kindly rewrite the title where we have X is normally distributed with mean, where we have 2, and the variance. So kindly rewrite the situation as the standard deviation square, where we have 3 to the power of 2. Next refers to the questions, where we have probabilities that x is greater than equals to 5. Since this is a normal distribution, so meaning that the sign is not important. So next, probabilities that x greater equals to 5. So in here, what we have to do is to standardize the situation. So where we have the formula for standardize the situation, where we have z is equals to x minus mu over standard deviation. Now what we have to do is to standardize the situation. Probabilities that x minus 2 over 3 greater equals to, where we have 5 minus 2 over 3. Simplify the situation. Probabilities that z, so meaning that we already standardized the situation, greater than equals to 5 minus 2, where we have 3. 3 over 3, where we will have 1. So that will be the situation after we standardize the situation. Next is to sketch the graph. So kindly refers to the graph, where we have z is greater than equals to 1. So where we have here is 1. So question mentioned that z must be greater than equals to 1. So here will be the situation. So kindly refers to the table. So here we have the table of standard normal distribution. So by referring to the situation just now, z is greater than equals to 1. So by referring to the situation where we have 1.0. So the probability for z is greater equals to 1 would be 0.1587. So here will be the probabilities that 0.1587. So the probabilities that x is greater equals to 5 will be 0.1587. Kindly refers to B, where we have the probabilities that x is greater than 1. So previously we already mentioned that sign is not important because this is the normal distribution. So before that, step number 1, what we have to do is to standardize the situation. Probabilities that x minus 2 over the standard deviation, where we have 3, greater than 1 minus 2 over 3. Simplify the situation. So probabilities that z is greater than negative 1 over 3. So in here, 1 over 3 will be 0.33. Next, refers to the diagram. So here we have the diagram. So kindly plot the location where we have z is equals to negative 0.33. By referring to the situation, z is greater than negative 0.33. So here will be the situation. Next is to rewrite the situation, or we have a formula in order to find the area under the curve. So here we have the situation. Kindly modify the situation. It become the positive 0.33. And if we flip the situation, here will be the region under the curve. So rewrite the formula where we have 1 minus the probabilities that z is greater than 0.33. So in here, probabilities that z greater than 0.33 will be this part. So we are going to eliminate this part where we have probabilities that z greater than 0.33 in order to find the area under the curve or the shaded region. So by referring to the table, in order to find the probabilities that z is greater than 0.33. So here we have the tables of the standard normal distribution. So given that z greater than 0.33. So in here we have 0.33. So here we will be the 0.03. So this will be the 0.33. And the probability under the curve will be 0.3707. So in here, 1 minus 0.3703. So simplify the situation and we will have the probabilities that x greater than 1 is equals to 0.6293. Kindly refers to C, where we have the probabilities that x is less than equals to 0. So do remember, sign is not important because this is a normal distribution. So what we have to do is to standardize the situation. So probabilities that x minus 2 over 3 less than equals to 0 minus 2 over 3. Simplify the situation. Probabilities that z is less than equals to negative 2 over 3, where we will have negative 0.67. Next is to sketch the graph. Where we have the location of z, where we have negative 0.67. Refers to the question, z is less than equals to negative 0.67. So the region will be on the left. So as we all know, our table is greater than. So what we have to do is to flip the situation. So where we have 0.67, so here will be the shaded region. So rewrite the formula. So probabilities that z is greater than equals to 0.67. So by referring to the table, so here we have the tables of standard normal distribution. So z is greater than equals to 0.67. So here we have 0.6. So do remember, z is greater than 0.67. So here we will have 0.07. So this one will be the 0.67, where we have the probability 0.2514, or we can say the region or the area under the curve. So probabilities that x is less than equals to 0, the probability will be 0.2514. Kindly refers to D, where we have the probabilities that x is less than 3. So as we all know, step number 1 is to standardize the situation, where we have the probabilities that x minus 2 over 3 less than 3 minus 2 over 3. So simplify the situation. Probabilities that z is less than 1 over 3, where we have 0.33. Second step is to refer to the graph or sketch the diagram. So locate the 0.33, and by referring to the question, z is less than 0.33. So where we have the left hand side will be the shaded region. So as we all know, our table is a greater than table. So what we have to do is to rewrite the formula, where we have 1 minus. So we are going to eliminate this region. So the formula will be probabilities that z is greater than 0.33. So kindly refers to the table. So here we have the tables of the standard normal distribution, 0.33. So here we have 0.3 and here we have 0.03. So z is greater than 0.33 will be 0.3707 as the area under the curve. So where we have 1 minus probabilities that z greater than 0.33, where we have 0.3707. Simplify the situation. Probabilities that x less than 3 will be equals to 0.6293. Next, kindly refers to E, where we have the probabilities that x is greater than 2 and less than 4. So step number 1 is to standardize the situation, where we have probabilities that x minus 2 over 3 greater than, where we have 2 minus 2 over 3 less than 4 minus 2 over 3. Simplify the situation. Probabilities that z is greater than 0 and less than, where we have 4 minus 2, where we have 2 over 3, which is 0.67. After we standardize the situation, next is to sketch the graph or refers to the diagram. Kindly refers to the diagram, locate the situation where we have 0 and 0.67. Refers to the questions, probabilities that z is greater than 0 and less than 0.67. So kindly shaded the region. So here will be the region. Next is to write the formula. So by referring to the situation where we have probabilities that z is greater than 0. So we will have this part greater than 0. Then what we have to do is to eliminate this part where we have minus probabilities that z is greater than 0.67. Next is to refer to the table where we have to refer the 0 for the z and then 0.67. So here we have the tables of the standard normal distribution. So what we have to do is to refer to z is greater than 0. So in here we have 0. So the value for 0 will be 0.5. Next is to refer z is greater than 0.67. So here we have 0.6 and then here we have 0.07. So the value for 0.67 will be 0.2514. So in here we have probabilities that z greater than 0 will be 0.5 minus probabilities that z greater than 0.67, the value will be 0.2514. So kindly simplify the situation. So the probabilities that x is greater than 2 and less than 4, the probability will be 0.2486. Kindly refers to f, where we have the probabilities that x is greater equals to 1 and less than equals to 6. Step number 1 is to standardize the situation. So where we have probabilities that x minus 2 over 3 greater equals to 1 minus 2 over 3 less than equals to 6 minus 2 over 3. Simplify the situation. So probabilities that z is greater equals to, where we have 1 minus 2, where we have negative 1 over 3. So we will obtain negative 0.33. Less than equals to 6 minus 2, where we will have 4 over 3 and we will obtain 1.33. Next is to refer to the diagram. Next is to locate the value where we have negative 0.33 and we have 1.33. So by referring to the questions, probabilities that z is greater equals to negative 0.33 and less than equals to 1.33. So the region will be in between the value. So what we have to do is to eliminate this part and this part as well. So rewrite the formula. So where we have 1 minus bracket, eliminate the first part on the right hand side where we have probabilities that z is greater than 1.33. Another part where we have to focus on the left hand side. So kindly refers to the diagram. If we flip the situation and it will become 0.33. So in order to eliminate this part, so it will be named as probabilities that z is greater than 0.33. So kindly refers to the table where we have to look for the value of z, 1.33 and 0.33. So at first, what we have to do is to refer to the table of standard normal distribution with the value z, 0.33, where we have 0.3 and 0.03. So here will be the value for 0.33, which is the probability, where we have the probability 0.3707. Next is to find 1.33. So here we have 1.0. So here we have 1.3 and we have the 0.03. So here we will have 1.33. So with the value 0.0918. So kindly substitute the value. So here we have 1 minus bracket 1.33 where we have 0.0918 plus with 0.33 and we will have 0.3707. Simplify the situation. So the probabilities that x is greater equals to 1 and less than equals to 6 will be equals to 0.5375. Kindly refers to G, where we have the probabilities that x is greater equals to -3 and less than 1. So do remember, this is a normal distribution, so sign is not important. So step number 1 is to standardize the situation. So where we have the probabilities that -3 minus 2 over 3. So here we will have z after we standardize the situation less than 1 minus 2 over 3. Simplify the situation. So probabilities that z is less than equals to where we have -5 over 3, which is -1.67. Less than 1 minus 2 where we have -1 over 3, -0.33. Next is to refer to the graph. Locate the value where we have -1.67, -0.33. So the region will be this part. So my suggestion is to rewrite the formula or flip the diagram. Locate the value 0.33 and 1.67. So here will be the region. So the formula would be probabilities that z is greater than 0.33. So meaning that from here, move to the right. Minus, remove this part where we have probabilities that z is greater than 1.67. So kindly refers to the table. First is to find the value of z with 0.33. So here we have 0.3 and 0.03. So the value for 0.33 will be 0.3707. Next is to find 1.67. So here we have 1.6 and we have 0.07. So the value for 1.67, the probability will be 0.0475. So kindly substitute the value. So for z is greater than 0.33 where we have 0.3707 minus for the z greater than 1.67, the value will be 0.0475. Simplify the situation. Probabilities that x is greater equals to -3 less than 1 and the value or the probability will be 0.3232. Kindly refers to H, where we have the probabilities that modulus x minus 3 less than 2. Refers to the definition for absolute value. Modulus for x minus 3 less than 2 can be defined as n, where we have probabilities that x minus 3 greater than -2 and less than 2. Simplify the situation. So probabilities that x is greater than where we have 3 minus 2, which is equals to 1, less than 2 plus 3, where we will have 5. Next step is to standardize the situation. So probabilities that z is greater than 1 minus 2 over 3, less than 5 minus 2 over 3. Simplify the situation. Probabilities that z is greater than where we have -0.33, less than where we have 1. Next is to refer to the diagram. Locate the value where we have -0.33 and we have the value 1. Next is to shade the region. Then refers to the diagram, create the formula. So here we have 1 minus the probability is that Z is greater than 1 for the right hand side. Next is to eliminate the left hand side where we have minus probability is that Z is greater than 0.33. Refers to the table. So here we have the tables of standard normal distribution. First, what we have to do is to find 0.33. So here we have 0.3 and here we have 0.03. So the probabilities for 0.33 will be 0.3707. Next is to find Z greater than equals to 1, where we have 1.0. So the value will be 0.1587. So kindly substitute the value, where we have 1 minus, for Z greater than 1, the value will be 0.1587 minus with, for the value Z greater than 0.33, where we have 0.3707. Simplify the situation. Probability is that modulus x minus 3 less than 2 will be equals to 0.4706. So here we are, and thanks for watching.